So the goal of this video is to derive an explicit forward differencing scheme for calculating the time-varying temperature profile in a bar. And what we have is this is all the same bar, but I'm going to write out each one would be at a different time, and that'll come into play later. But if we wanted to write out the unidirectional heat diffusion equation with heat generation, what we would have is the second derivative of temperature with respect to position plus our Q dot over time is equal to 1 over the thermal diffusivity. And I forgot to mention in the last video, alpha is the thermal diffusivity, and I just said alpha, but what we have is that is equal to 1 over the thermal diffusivity times the partial derivative of temperature with respect to time. And that's with heat generation. So then if we wanted this equation without heat generation, we would write that, and that's the same equation that I had in the last video, where we have that the partial derivative of temperature with respect to time is equal to the thermal diffusivity times the second derivative of temperature over, or with respect to position. Wow, that's awful. Let's try and write that again. The second derivative of the temperature with respect to position. And so if we wanted to write out the temperatures at different times, we could say that this is the bar at time is equal to 0, and then we could say that at time 1, we could say that this is equal to delta T, and then at time 2 that it's equal to 2 delta T. Wow, this is like one of the hardest things I've ever had to do. So what we're going to do is we're going to find the temperature at the bar in the bar at different times. And so if we said, okay, let's find it at time 1, 1, 2, 3, 4, 5. Let's find it at bar position 5. That would be, we're going to write it as, let's do that in, can I do a different color? Let's do pink. Okay. So we're going to say that we're going to write it with temperature, and we're going to write it as J as our position in the bar, and N is our time. And so since we have the equation that partial derivative of temperature with respect to time is equal to the thermal diffusivity times the second derivative of temperature with respect to position, for this part we could say, or for the left side of the equation, we can say that in the bar we have that our time, or our temperature at position 1 at time n plus 1 minus the temperature of the bar in the same position at the previous time, or at our next time minus our current time, divided by the change in temperature is equal to, we're going to carry our thermal diffusivity through the equation. So let's do purple for this one. We're going to carry our thermal diffusivity through, and this part of the equation can be expanded and written as thermal diffusivity times the partial derivative of, partial derivative of with respect to x times our partial derivative of temperature, or derivative of temperature with respect to position. And so with that, we can say that our bar is going to be our temperature at our next position at our current time minus the temperature of the bar at our current position at the current time divided by our position. And then we want to continue on, and we want to subtract the temperature of the bar at our current position at our current time minus the temperature of the bar at the previous position at the same time divided by the position, sorry, I keep thinking somebody's going to walk in, the position, or the change of position, and we're going to divide this entire equation by our position. Gosh, why is it? I don't want it to look like a 4. Our position in the bar again. And so if we removed this bottom part of the equation, this is only the first derivative. So if we want the second derivative, we need to divide by our position again. And so continuing on, all we need to do now is a little bit of algebra. And so what we're going to write is that the temperature, again, I'll change the color here. Let's do light blue. The temperature of the bar in one position at the next time that we want to measure the temperature of the bar is equal to the temperature of the bar at our current position and our current time plus the thermal diffusivity times the temperature of the bar in our current position, or the next position, I apologize, at this current time that we're checking for the temperature of the bar, minus, because again, we're just multiplying these two equations together, minus 2, that's actually a 2 this time, times the temperature of the bar at our current position and time, plus the temperature of the bar at the previous position at our current time, times, we need to multiply by our change in time for, well, again, we're going to say for this bar, I need to pan down, sorry, divided by, and this whole parenthetical is divided by our second derivative with respect to x. And so to clean that up, what we'll say is that our temperature in the bar at our current position plus, or our current position at our next time is equal to the temperature of the bar at our current position and our current time plus the thermal diffusivity times, well, our change in time divided by our change in position squared. And that is, or we're multiplying our parenthetical next position current time minus 2 times our current position and current time in the bar plus our temperature of the bar at our previous position and our current time. And so what this gives us is a unilateral, or not a unilateral, our forward differencing scheme for calculating the temperature at a specific point in the bar.